In this video, I will talk about kernels, which is very important to understand convolutional neural network. CNN is a recently popular approach to performing image recognition, which working principle is learning and concluding the characteristics from substantial input image data samples. The general convolutional neural network architecture you can see here from the figure, you have input layer, which is the image, and then convolutional layer, pooling layer, convolutional layer, pooling layer, and so on. These we call it filter. Then the step of classification. We use fully connected layers, and this is the final output to classify the image. Let's see the pattern detection in CNNs. As you can see, this is the upper left beak detector. We use sigmoid function. And this is the second image, middle beak detector. They can be compressed to the same parameters. However, for image data, repeating patterns can occur in different places. Hence, we can train many smaller detectors capable of sliding across an image to take advantage of the repeating patterns as shown in the previous figure. This would reduce the number of weights required to be trained. A CNN is a neural network with some convolutional layers and some other layers. I will explain in future videos. A convolutional layer has a number of filters that does the convolutional operation. And in this video, I will explain what is the convolutional operation mathematically. One of the main components of CNNs are filters, which are square matrices that have dimensions nk by nk, where nk is an integer and is usually a small number like 3 or 5. Sometimes we call it kernels. Using kernels comes from classical image processing techniques. If you have used Photoshop or similar software, you are used to doing operations like sharpening, blurring, and so on. All those operations are done with kernels. Let's define 4 different filters, and let's check later their effect when used in convolution operations. For those examples, we will work with 3 by 3 filters. The following kernel will allow the detection of horizontal edges. We call it S tilde H. So this is the matrix of it. 1, 0, -1, 1, 0, -1, 1, 0, -1. So this will detect horizontal edges. The following kernel will allow the detection of vertical edges. We call it S tilde V. So this is 1, 0, -1, 1, 0, -1, 1, 0, -1. The following kernel will allow the detection of edges when luminosity changes drastically. As you can see, we call it S tilde L, -1, -1, -1, -1, 8, -1, -1, -1, -1. The following kernel will blur edges in an image. So we call it S tilde B equals to -1/9 and times 1 matrix. In the future video, I will show you the convolution operation.